In this video, you're going to learn about Fuel. I'm hoping to give you the most comprehensive overview in the shortest amount of time so you can walk away understanding what Fuel is, how it works, and how to build applications with it. This presentation is going to be broken up into two parts. We're first going to deep dive into Fuel, talk about what it is, how it works, and what sets it apart. We're then going to start from scratch, building out smart contracts, testing them, deploying them, and building out a front end to interact with them. By the end of this video, you should have an understanding about what Fuel is, how it works, and how to build full-stack applications using Fuel, Sway, and the Fuel Toolchain. Fuel describes itself as the world's fastest modular execution layer. As we've seen in the past year or two, blockchains are moving away from a monolithic design where consensus, data availability, and execution are tightly coupled. Modular blockchains are built specifically for this exact use case. With modular blockchains, execution is separated from data availability and consensus. This design allows for specialization at the base layers, delivering a significant increase in bandwidth capacity. Fuel has been built from the ground up with this in mind and is building an execution layer specifically for the modular blockchain stack. So what sets Fuel apart? With the Fuel virtual machine, Fuel learns from predecessors of the past and previous VMs like the EVM, Solana, Bitcoin, and Cosmos, and offers a very specific blockchain-optimized virtual machine. Unlike the accounts model of the EVM, Fuel uses a system of UTXOs which enables a more efficient system of transfer and ownership of assets, where the accounts tree doesn't have to be rebuilt every time funds are transferred. The Fuel VM has a globally shared memory architecture. Instead of every contract call having its own separate memory space, call data, and return data, all contract call frames share global memory. This chunk of memory is shared amongst all call frames and is globally readable. This allows you to pass data around between contracts without expensive storage and pass chunks of data without having to serialize, copy, and call data to memory. Fuel is fraud provable. Fraud proofs are a blockchain verification mechanism whereby a claim on a new block is accepted unless a proof that the claim is invalid is provided within some configurable time window. An advantage of fraud proofs is that they're not necessary for each state transition, which means fewer computing resources. This also allows trust-minimized light clients to be secure under the assumption that only a single honest full node is available in the network to produce fraud proofs. Fuel utilizes a parallel execution scheme under the hood via strict mandatory access lists enabled with its UTXO model. Ethereum and most other virtual machines process transactions sequentially. With modern processors becoming increasingly multi-threaded, being able to execute transactions in parallel is a highly desirable property. Multiple threads allow your environment to execute multiple parts of a program or, with a blockchain, multiple transactions at the same time. Fuel takes advantage of parallelizing over multiple cores and threads and is not limited by being single-threaded like most pre-existing blockchain VMs, and therefore is extremely fast. Fuel also introduces its own new programming language called Sway. Sway is a developer-friendly Rust-based DSL or domain-specific language created specifically for writing smart contracts. Sway includes syntax to leverage a blockchain VM without needlessly verbose boilerplate, which is abstracted away nicely with the language. Sway has a compiler that can detect programming and blockchain-specific errors and notify you before you compile your contract. Sway has a language server, a canonical formatter that can even format files like manifests, and a VS Code plugin with syntax highlighting and error reporting. The compiler can detect things like match expressions that are not exhaustive or detect re-entry attacks and bugs. And finally, Fuel is set apart by its overall developer experience. As mentioned before, Sway offers a very nice developer experience for building smart contracts and abstracts away a lot of the lower-level boilerplate that you may have seen in other Rust-based smart contract environments. Fuel also introduces Fork, the Fuel orchestrator. Fork allows you to initialize, test, and build and deploy smart contracts easily directly from your command line, and is integrated directly with the rest of the toolchain, including Sway. Fuel also offers its own indexer that's a standalone service that can be used to index various components of your app. These indexable components include blocks, transactions, receipts, and state within the network, allowing for high-performance read-only access to the blockchain via GraphQL for advanced dApp use cases and UX. Fuel also offers a host of its own SDKs and libraries for interacting with and building on Fuel, including the Fuel TypeScript library, which we'll be using in just a moment. And finally, Fuel is built for the modular stack, aiming to provide the highest possible, most flexible throughput while still delivering maximum security. Now that we've been introduced to Fuel, let's learn how to build a full stack application using Fuel smart contracts, the Fuel Toolchain, Sway, and TypeScript. Before we get started, I want to go over a couple of resources together. The first is the Fuel book. This is what we're going to be following along for our developer quick start. Next is the Sway book. This obviously dives more into the Sway programming language if you want to go beyond Hello World, which we're going to be kind of covering today, and you want to learn anything about the language, this is a good place to start. Beyond that, in the Sway applications repo is a set of really great smart contracts that are already built out for things like DAOs and NFTs. There's also the Sway examples repo. So if you go to Fuel Labs/Sway, then you'll go to examples, and this is a kind of a collection of maybe smaller contracts than the full end-to-end applications. Even though there are a few end-to-end applications here, they're basically trying to show you how to implement certain features. There's also Awesome Fuel. This is a really great resource that will keep you busy for a very long time. There are articles here, there are videos, podcast interviews, events that are coming up. And I think combining the Fuel book, the Sway book, and those repos that I just showed you should keep you very busy learning all of this stuff. And I think that if you kind of take what we're going to cover today along with all of those things, you can get pretty far. But today we're going to be doing the quick start guide, and this is going to be broken up into two parts. The first is building a smart contract. During this tutorial, we're going to be writing Sway code. We're going to be compiling that. We're going to be deploying that to the network, and we're also going to be testing that. So this covers quite a bit. And then in the second part, building a front end, we're going to connect to our smart contract that's been deployed, and we're going to test it out in the browser, and we're also going to download the Fuel wallet. And I think by combining and putting all this stuff together, you should have a good overview about how all this stuff works together and how to build things that are a little bit more sophisticated than this example that we're going to be doing. So with that being said, we're going to go ahead and get started. For you to build with Fuel, you need to have the Rust toolchain installed. We have a link here in the quick start how to do that. You should follow that and then continue on after you have Rust installed. From there, we're going to click on installing the Fuel Toolchain, which is Fuel Up. And this is going to be a pretty simple installation. The only thing we need to do is copy and run this curl command. And once you've run that, you should be able to just drop it here in your terminal. And once you run that, you should be able to have Fuel Up available to you. And this will give you, an overview of what's available from that. And with Fuel Up, you can now do a lot more with that. So we have a couple of different binaries that we'll be touching on in just a moment. But the one thing that we want to cover next is updating to have the most recent versions of Fuel available. So we can run Fuel Up self-update, and this should go ahead and update everything for you. And then beyond that, we want to have work with different tool chains. And the cool thing about Fuel is that you can install various tool chains and switch between them pretty easily, almost how like a Node version manager or Ruby version manager would allow you to swap between different versions of those library or those frameworks and languages and stuff. So what we can do first is we can run Fuel Up show, and this will show you the current installed tool chains that you have and the active tool chain that you're on. Now, for this tutorial, you can either follow along with the latest version, or you can use the current version that is in the documentation. Now, I'm doing it this way because if you want to follow along with anything in the documentation, it will continue to evolve and change. And it should always work. So if you want to follow along, I would say the differences between what I'm doing and what's in the documentation are very minor. So the docs and the quick start guide should always be up to date. But instead of using beta 3, I'm going to be on the latest version. So there are going to be a few minor differences between what I'm writing versus what's in the docs. So that's why if you look at my Fuel Up show, you'll see that I'm on the latest version. So now that we have our version set, so if you wanted to set your version as beta 3, you would run this command here, Fuel Up default beta 3. And then you could run Fuel Up show, and that would show your active toolchain as the beta 3. And I'm going to then update mine to be the latest. Okay, so now that we have Fuel up ready to go, we can create a new project using Fork, which is the Fuel orchestrator. So I'm going to create a new folder called Fuel Project. And then I'm going to run the command fork new counter contract. And if we look in this directory, we have this new counter contract. And I'm going to go ahead and open all this up in my text editor. And here in our src directory, we see our first Sway file. And Sway is very similar to Rust. It's kind of like a domain-specific language that's built on top of Rust, but specifically for smart contract development. So now that we have this ready to go, we want to go ahead and write our contract. The contract that we're going to be writing is very basic. It's going to be for a counter. We're going to start with a count of 0, and then we're going to increment that. And you can also obviously add additional functions like decrement or set a specific number. I don't know. But this is just going to show you how to write the different portions of your contract, like the ABI, and how to compile this and how to deploy this and how to actually interact with this further along. So at the top of every file, we need to define exactly what it is. So in this case, we're just saying this is a contract. There are other options that this could be, like a library, and we're going to maybe touch on one or more of those later. But for now, we're just saying this is going to be a contract. Next, we're going to set the storage value of counter to 0. This is how you update and manage state that is shared between different functions, and you have to then access this via that storage value. So we're going to be setting the only storage value in our case is going to be a counter, and this is going to be a number that we increment and also return. The next thing we want to do is define our ABI, which is kind of like the interface. This is not the actual functionality. This is just us saying there is going to be a function called increment that is going to access storage, and there's going to be a function count that's going to access read storage. And then in the actual implementation, that's where we write the actual functions. So we can then go next beyond the ABI, and we can say the counter for contract. And then this is going to be where we go ahead and implement these two functions. So the first one that we're going to implement is going to be read. And I'll go ahead and implement the other one so we can get rid of that syntax error. Okay, so here we have function count that returns a U64, and this basically is going to call that storage, and we're going to say storage.counter.read, and this is going to return the value, the state. For increment, we're going to be calling storage.counter.write, and then we're going to be passing in the current value of the storage counter plus 1. And that is about it. You know, it's very simple. We don't have a lot going on here. This is just kind of like a hello world type of example. What if we, though, wanted to build out something more sophisticated? You might start breaking up your app into, or your smart contract into multiple files. So let's see how to do that. So a lot of times you'll take this ABI and you'll separate this into kind of like an interface. So what we're going to do now is create a new file called interface.sw. And here, instead of calling this a contract, we're going to call this a library. And then we can just go ahead and drop that ABI there. And then we can now use that as a module. So we can say mod interface. And then we can say use interface counter. And we should be good to go there. So now we're kind of importing that counter ABI, and that way we're separating some stuff out of our file. Okay, so we are ready to continue on now. So what we're going to do is build our contract. So we're going to be using the Fuel orchestrator fork command. And what we should be able to do is run fork build. I need to actually change into the right directory, and then we'll try that again. If fork build is successful, we should have now a out directory here. So for out, we have a couple of different ABIs and JSON that's been created here. So the build command has worked. We also have a new lock file for our fork.toml. And this, by the way, is kind of like a package.json would be in JavaScript. It's a configuration file. Now we want to go ahead and test this out. So you can write tests in a couple of different ways. You can write unit tests in Sway, or you can write an integration test in Rust. So we're going to do an integration test, or kind of like an end-to-end type of test using Rust. And to do that, you need to install cargo generate. So you would go here to your command line, and you would run cargo install cargo generate. That takes a while. I've already done that. So if you haven't done that yet, go ahead and do that and pause this video and come back. And then now we're going to go to the next step, which is right here. We're going to say cargo generate init or --init fuel labs/sway. We're going to set the template as templates/sway test-rs, and we're going to set the name. But if we just go ahead and run this, this will go ahead and initialize a test for us locally. So if that was successful, we should be able to go here to our IDE and see that we have a new test folder with a harness.rs. And everything above this Tokyo test is just the initialization and the setup for your test. So you don't have to really worry about any of that, but everything that we're going to be doing is going to live right here. All right, so for that to work, we're going to go down here and we're going to go ahead and call get contract instance.await. And then we're going to go ahead and call the increment method. And this is going to take the value of 0 and increment that to 1. Next, we're going to get the current value that is stored by calling count. So we're getting an instance of this deployed contract. We're calling increment, and then we're getting the current value. So if we called this once, the return value should be 1. If we call it twice, it should be 2, etc. And what we can do now is call assert equal, setting the value that we're expecting is 1 and the value here. So here, if we go to our command line and we run cargo test, and if the test is successful, you should get some output like this saying test result okay. So if we want to break this test, we should be able to do something like this, like see if the result value is 2 and assert, and then that should come back as a failing test. Or we can consider calling increment twice, and then this should pass because the value should actually be 2. So our test seems to be working good, and now we can kind of move on to the next step. So what do we want to do next? Well, we want to go ahead and deploy the compiled contract. So to do that, we're going to need to do a couple of things. First, we're going to make sure we have the wallet CLI installed. This is going to be fork wallet. This might already be installed with the Fuel Toolchain. You can run fork wallet to see. And if it's installed, you should get something like that. And what we're going to need to do is create a wallet and then create an account within that wallet. So once you've made sure that you have the wallet installed, then we're going to go here to the wallet docs, and we're going to go down here where it says fork wallet new, and we're going to go ahead and run that command here. And you'll type in a password that you're going to use again later. and you're given a mnemonic phrase. This is going to be a wallet I throw away, so I'm not worried about sharing it here. And now we should have a wallet installed or created, and we should now be able to create an account. So once we have the wallet, we can run fork wallet account new. And then it'll ask for that password, and it'll create a wallet address at the index of 0. And that index is kind of important because in a moment, we're going to be referring to that address by the index. So if you created another wallet, the new one would be 1, and so on and so forth. And we can run fork wallet accounts to see the accounts that we have. So in our case, we still just only have that one account. Okay, so now that we have the wallet set up and we have an account, what we're going to do is going to go to the testnet faucet. There's a link to it in the docs, but you can also go to faucet-beta-3.fuel.network, or if this is on a future beta, then it might be 4 or something else. But we're going to take that address that was given to us from our command line, and we're going to drop it right here. And we're going to request some testnet funds, because we're going to need to have some funding in our wallet in order to deploy our contract. So after that has been sent, you can go to the Explorer here and see that that went through, hopefully. And then what we're going to now do is run this command. We're going to say fork deploy, passing in the node URL, passing in the gas price, and this -- random salt. So I'll go here, I'll run that command, and it's going to ask for the address of our wallet. So we can just copy that wallet address here, paste it, and if you've received the funds correctly, this should then ask you to sign a transaction, and it'll give you the transaction ID to sign. So what we want to do now is we're going to go into a separate window, and we're going to say fork wallet sign -- account. And we want to pass in the account index of this wallet here, which in our case is going to be 0. And then we want to pass in the transaction ID, which is going to be that one, by passing in TX ID. And then we're going to hit enter. And this is going to ask for our password. And then this should give us a signature. What you're going to do is copy that signature to your clipboard, paste it right here. And if this is successful, then you should be given a confirmation that the contract was deployed, and we can now kind of move on to the next step. So we've deployed our contract to the network, and we have the contract ID. And what we can now do is connect to that from our front end. We can actually look at that in the Fuel Explorer as well. So let's take a look at that transaction ID. And the Fuel Explorer is at fuellabs.github.io/blockexplorer. And it looks like we have that beta 3. And I think we need to add like 0x to this. Yeah, so you add 0x to the transaction ID, and then you can kind of see it here in the Explorer. But we're done, though, with all the smart contract stuff. What we're going to do now is go to building a front end. And in order to do this, we first need to install the Fuel browser wallet. So we can go to wallet.fuel.network. And we're going to go ahead and click Download Fuel Wallet. And once that is downloaded, you can go into your browser extension here and click Manage Extensions. And I believe you might need to have a developer mode enabled. And then you can click Load Unpack. Now, in the future, the browser wallet might already be in the extension store, by the way. So this might be outdated. I would just follow, again, whatever it says in the tutorial. But for now, we need to go ahead and click Load Unpacked. And wherever you downloaded that wallet, just go ahead and drop that in. And go ahead and click Create Wallet. It'll give you a seed phrase, which you'll copy. You'll click next. You'll go ahead and enter that seed phrase. And obviously, if you're planning on keeping this wallet, write this seed phrase down somewhere and don't expose it to anyone. But I'm going to delete this after this. So, and then you're going to go ahead and enter your password. And then we now have successfully created our wallet. And what I'm going to do is go ahead and set the Fuel wallet as a pinned, app in my extensions. And what I'm also going to do is I'm going to copy this address, and I'm going to go back to the Fuel faucet, and I'm going to go ahead and request funds to that wallet as well, because what I want to do is also use this wallet to interact with my app from a client-side application in just a moment. So we have the Fuel wallet installed, and I have 0.5 ETH, and I should be able to continue on. So I'm going to go ahead and initialize a new React project by running npx create React app front end, and we're going to set the template as TypeScript. And this needs to be one directory up. It doesn't need to be in the same directory as your smart contracts. So one directory up. We'll let that install. And what we're going to then do after we have our new app, our client-side app installed, is we're going to change into that directory, and we're going to install two dependencies. One is Fuels, and I would install this at the version that is noted in the doc. So in this case, it's version 38. And we're also going to install the Fuel Wallet SDK. And I'm going to do this using Yarn, but you can do this using npm or pnpm or whatever you like. Okay, so now that we have that installed, we need to update our compiler options and our TypeScript configuration. And here we're going to go ahead and just make it aware of our types. So we can just add this Fuel Wallet SDK as one of the types in the array of types. So we can close that. We can actually go ahead and close everything. And what we're going to need to do next is go ahead and open the front end directory, go into the src directory and open app.tsx. And we can probably go ahead and just delete all of that stuff that we're starting off with. And we're going to start by importing React, use effect, and use state from React. We're going to go ahead and import the Fuel Wallet SDK, and we're going to go ahead and import the CSS. Next, we're going to need to have a reference to our ABI. And to do that, we can actually go ahead and use npx, and Fuel will actually go ahead and generate all these things for us. So we can run npx fuels type gen, and this will go ahead and create some types for us to use along with like an ABI definition. So I can run this command here. Make sure you run this from your front end directory. And you'll see that we have 3 directories now, but after I run this, we now have actually in our directory of src is where it's been. We now have this new contracts directory. And then once we have that directory, we can go ahead and import a reference to the counter contract ABI from contracts. Next, we want to go ahead and set the contract ID to be the contract ID from our deployed smart contract. And for me, that is this contract here. Next, we're going to go ahead and define our main function here for the app. And we're going to go ahead and grab some initial state that we're going to be working with. And we're going to be able to basically follow along exactly with, again, what's here in this quick start guide. We're going to have a couple of pieces of state. We're first going to check to see if the browser wallet is connected. And if it's not, we're going to have a function called setConnected to connected. We're going to have a variable to hold the user's account ID or account number, and we're also going to have a function to set that. We're going to have a function to get the current value of the counter and also set that as well. So by default, when the app loads, we're setting it as 0, but once the app actually calls the network and gets the current value, it will reset that. And then we'll also have a function to set that on the client. And then we have a function called loaded and set loaded, and this will allow us to show and hide UI based on whether the app is loaded. Next, we're going to have a use effect hook, and this use effect hook is going to be invoked when the app loads. This is kind of like a lifecycle hook. And the functionality here will be also updated if this value here changes. So by default, connected is set to false. This check connection function is actually going to be toggling connected. So this is going to be all kind of tied together after we write that check connection function, which we'll go ahead and do now. So check connection is going to see if we have that window.fuel variable available, and it's going to see if that window.fuel.isConnected returns true or false. This is a really great way to just see if the user's already logged into your app or not. If they have, then this connected will come, or is connected will come back true, and you can go ahead and update the state like we're doing in just a moment. It just provides a better UX than asking the user to connect their wallet every time. We're also going to need a function for the user to connect if they haven't connected before. So we'll create a function called connect. And this will allow the user to click a button to connect. And we'll call window.fuel.connect. This will pop up the Fuel wallet. The user will connect with the wallet they would like to connect with, and we'll go ahead and set that account in our local state. And then next, we're going to have two functions that interact with Fuel. One is going to be called getCount. That will do just as like you think is getting the current count value. And we're going to call window.fuel.getWallet. And then this is going to be where we actually connect the wallet using the contract that we deployed. And then we can start calling functions that are read-only in this case without having them sign anything. So here we're going to call contract.functions.count.get, and then that value will be returned, and this will be like 0 or 1 or whatever. And then we set that counter value in the local state, and later on we'll show that in the UI. And then finally, we'll have the function to increment. And this is going to be a little different than what we've done previously, because what we're going to be here essentially doing is invoking a transaction update, asking the user to sign. And that is done automatically really right here. So when we call contract.functions.increment, this is going to pop up and the user is going to have to sign this transaction in order to increment. And then after that's successful, we're going to wait for that to finalize. Then we're going to call getCount again, and then we're going to update the local state with the new count. You could also do an optimistic update here, I guess, and you can just call that, and if it fails, you might decrement the value for whatever reason. Next, we're just going to return null if the app isn't loaded, and this is not going to really show to most users, but it'll avoid throwing any errors or anything like that. And then finally, we're going to return our UI. So this is going to be what we return to the user. We're going to check if the user is connected. If they are not connected, we're going to show this big connect button. If they are connected, we have a button that we're going to show them to allow them to increment the counter, and we're going to show them the counter current value. So pretty simple UI. If they are connected, we'll show them the value and allow them to interact with the app. If they're not connected, we'll show them the connect button. And then finally, we'll add the default export to be this app component. And we will have our basic styling, which in our case is just a button style. And this can be whatever you want. You can see here we've done like border radius, background color to kind of give this the Fuel color. And that's kind of about it. We should be able to go ahead and run this app. So if I go to my command line and I'm in this front end directory, I should be able to run npm start. All right, so here we are. Our app has loaded. We'll click connect. We'll go ahead and choose the account that we'd like to connect with. And you'll see that the counter comes back to the current value. I've already deployed this and tested it out once, so I have a count of 1. But if I click on increment, this should prompt the user to approve the transaction. And then we're going to wait for that to go through, and you'll see that the counter is now 2. We increment again. The counter goes up to 3. And if we refresh, we see that the counter is up to 3. So beyond that, we've basically run and updated our app on the front end, and everything seems to be all integrated properly, and we don't have any issues. So that's kind of it on our front end part. So that concludes everything that we need for this tutorial. So I would say if you want to dive deeper into this, I would consider adding maybe more functionality to your contract and then adding more features on the front end to update those things and go through that iteration process of writing new code, compiling, and then testing out and stuff like that to kind of get a better feel for how you might do more with Sway. And I also encourage you to jump into those 2 repos I mentioned a moment ago, which were the Sway applications and Sway examples to continue learning. So that's it for this video. I appreciate you checking it out. If you want to learn more, please subscribe to my channel. And if you want to support me, like and share this video. Thanks a lot.